Welcome to This Explainer. Today, we're decoding a fascinating and honestly an absolutely crucial piece of our modern internet infrastructure. We are talking about IPv6 and IPv6 subnetting. If you're currently learning networking, you are exactly in the right place.
Did you know the internet was running out of addresses? It's completely true. With the massive explosion of smartphones, smart TVs, and literally every internet-connected device you can think of, our old system just couldn't keep up. We were running out of room, fast. And that is exactly why IPv6 was created.
Okay, let's dive into this. Section 1. The need for IPv6 and moving beyond IPv4.
At its core, IPv6 is our latest network layer protocol, designed to effectively route data between all these devices. To solve that massive address shortage we just talked about, it upgraded from 32-bit to 128-bit addresses. The result? 340 undecillion unique IPs. I mean, to put that insane number into perspective, you could assign an IP address to every single atom on the surface of the Earth and still have plenty left over. It's mind-blowing.
Now, looking at a 128-bit hexadecimal address might seem completely intimidating at first glance. It's huge, but we can actually shrink it down really elegantly. First, we just strip away any leading zeros in a given group. Then, we find the longest string of consecutive zeros and replace that whole chunk with a double colon. Just like that, boom, we compress this massive, complex string into something super clean and manageable for network administrators.
But IPv6 isn't just about giving us more breathing room. It is a massive technological upgrade across the board. It bakes security right into the protocol using IPsec. It features auto-configuration, meaning devices can practically set themselves up the second they connect. Plus, packet headers are simplified to allow for blazing fast routing. And honestly, the best part? Because we have virtually unlimited addresses, there is absolutely no need for NAT or network address translation anymore. Every single device can safely hold its very own public IP.
All right, moving right along to Section 2, IPv4 versus IPv6, a direct comparison.
When we line these two up side by side, it really shows why IP4 is becoming obsolete. We're evolving from a highly cramped 32-bit decimal system to a 128-bit hexadecimal format that gives us infinite space. Security goes from being an optional add-on to a built-in guarantee. And that tedious manual or DHCP configuration, it's completely replaced by seamless automatic configuration. It's a total game changer.
So let's jump into Section 3, understanding IPv6 subnetting and organizing all this massive new space.
Okay, so we now have this unbelievable, practically infinite address space, right? But the obvious question is, how on earth do we actually manage and organize it? Well, that is where IPv6 subnetting comes in. You can think of subnetting simply as the logical process of dividing one gigantic network into smaller, bite-sized subnetworks. It is the absolute key to making daily network management actually work.
IPv6 handles this division using something called prefix notation, and the most common structure is wonderfully symmetrical. It's the /64. So the first 64 bits strictly represent the network portion. You can think of that part as your specific neighborhood. Then the remaining 64 bits represent the host portion, and that's like your specific house inside that neighborhood. It splits it right down the middle.
Now, in the real world, these prefixes represent totally different scales of operation. A /48 prefix is massive, so it's usually handed out to really large organizations. A /56 is perfect for medium-sized corporate networks. The /64, like we just mentioned, is your standard everyday subnet size. And a /128? That zeroes all the way in to isolate one single individual device.
Which brings us to Section 4, Subnetting in Action, looking at a practical example.
To really see how the math works here, just look at how incredibly simple this division is. Let's say we start with a base organizational network, a /48. To break this down into those standard /64 subnets, we literally just increment the network portion by changing just one single hex value, 1, then 2, then 3. An organization can effortlessly spin up thousands of perfectly isolated subnets, all from one single base.
Let's wrap things up with Section 5, Subnetting Best Practices and Real-World Application.
So why does mastering this skill actually matter for your networking career? Well, because subnetting is literally what keeps real-world networks alive and kicking.
It logically separates vulnerable departments from general ones. It locks down security by strictly limiting access between those segments. It scales effortlessly for future growth, and it radically reduces traffic congestion by keeping local data, well, local.
But to get all those awesome benefits, you really have to follow best practices. First off, always use a /64 prefix for most of your standard networks. Make sure you plan your addressing architecture carefully before you deploy a single device. Religiously document all of your subnet allocations. I can't stress that enough. With so many addresses, a written record is your absolute lifeline. And finally, just keep your structures simple. Good organization definitely doesn't have to be complicated.
IPv6 is the future of networking, and understanding it today prepares you for tomorrow's internet. With 340 undecillion addresses right at your fingertips, the real question is, how will you architect the networks of tomorrow? Thank you for watching. If this explainer helped you understand IPv6 and IPv6 subnetting, please like this explainer, subscribe to the channel, and turn on notifications for more simple networking lessons.